Right, hello Year 7. I'm going to talk you through how to work out resultant forces, looking at the balanced and unbalanced forces that we did yesterday. So just moving on from what we did then. First of all, the answers to the quiz questions that you did. So the first bit, if I can get the mouse to work in the right place. Right, so these ones you needed to match up. So these are the correct answers, so you can check the ones that you've done. Now for this one, I asked you to just write next to each diagram whether it was balanced, balanced or unbalanced. So the first one, because there is no force opposite the forward movement, that is unbalanced because I've only got one arrow here. There's nothing working against it. So this is an unbalanced force, okay? And in that case, the car would move forwards. The second one, the forwards arrow again, is much bigger than the arrow trying to slow it down. So they are unbalanced because the arrows are different sizes. They're working in opposite directions and they're different sizes. So that makes them unbalanced. This one, the arrows are in opposite directions, but this time they are both the same size. So the forces on this car are balanced. And then the last one, this time you've got no forward arrow. So the only force acting on it is an arrow in the reverse direction. So that is, again, unbalanced. Okay, now this was the task that you needed to do. So for each of the scenarios, you needed to just draw a little picture, draw on the arrows, which direction it was, label them and say whether the forces are balanced or unbalanced. Okay, so I'll go through each of these so that you can check your own. So the first one, you've got a car that's sat at traffic lights, so it's stationary, it's staying still. So there is no forward force from the engine because it's not moving, and there is no friction. But in this case, because there's no forces working, then the forces are balanced. So that car will remain stationary because it's stopped. The forces are balanced, so it will remain stationary. Those two arrows are the same size. When the car starts to move forward, the engine, the thrust from the engine that makes it move, is going to be larger than the friction. It has to be larger than the friction to actually allow it to move. So in this case, the forward thrust is bigger, and in that case, the forces are unbalanced. This one, the car's slowing down. So this time, when you put your foot on the brake, you increase the amount of friction with the tyres, and that is going to be a force that slows it down. So this time the friction force is bigger than the engine thrust, bigger than that force pushing it forward. So the car will slow down, and again those forces are unbalanced. So friction is larger than thrust this time. You've got a skydiver, he's jumping out of the plane. So to begin with, his gravity is bigger than the air resistance that's trying to slow him down, so he will be unbalanced. So to begin with, he's going to fall very, very quickly. So gravity is working much more. Okay, so that arrow, that force arrow, is much bigger than the wind or the air resistance that's actually pushing him back up and trying to slow him down. However, when he opens the canopy, when he actually opens his parachute, there'll be lots more area for the air to get trapped underneath. So that will increase the size of the air resistance, so that it matches the gravity, so he will fall at a steady speed. So that means the forces are now balanced. So he will still fall because gravity is still working on him, but this time it's being balanced by the same amount of force actually holding him up with the air under the parachute. So those forces are balanced. Okay, so we don't need to do that bit. Right, okay, so just recapping what we said, we need to show the arrows. The direction shows the direction of the force, the direction of the arrow shows the direction of the force, and the length or the size of the arrow shows the size of the force. This was the ball that you looked at yesterday. So in this case, the weight, the gravity arrow, is bigger than the air resistance arrow. They're unbalanced, and this ball is going to be falling because the weight arrow is bigger, the weight force is bigger. Okay, now forces are measured in newtons, are named after Sir Isaac Newton, and what we're going to do is we're going to start putting some numbers to these forces. So rather than just giving them the arrows a size, we're going to actually start putting some numbers to them and figure out what's going on. So in this case, you've got two forces working in opposite directions. Like the force meters yesterday, there is a force of 10 newtons in each case. So in this case, the forces are balanced. If the box is not moving, then it will stay still. So it will stay exactly where it is because the forces in the two directions are the same. If it was moving, then it will continue to move at the same speed. Okay, so the resultant force, the 10 newtons on the left, cancel out the 10 newtons on the right. So that's going to be a resultant force of 0 newtons because 10 minus 10 equals 0. Now in this case, you've got a 10 newton force on the left and a 3 newton force on the right. Now we need to look at the direction of the arrows. So this is pushing it towards the right, this is pushing it towards the left, even though it's on the other side. Now the numbers, because they're different size numbers, they are unbalanced. Now I hope you can figure out that 10 is bigger than a force of 3 newtons. So 10 newtons is much larger than a force of 3 newtons. So this one will sort of win. Okay, so the forces will be bigger on the left hand side, so that will cancel out. So I'm going to do my 10 minus my 3, and that gives me an overall force, a resultant force of 7 newtons, and it will be towards the right because that is the direction that the bigger force is pushing. Okay, so you need to be careful with the direction of the arrows because although it's on the left, it's pushing to the right. Okay, so the resultant force is basically one single force that replaces all the others that still has the same effect. So if we go back to this one, we could replace that with one arrow that is 7 newtons to the right. So we wouldn't need to have both of these, we could just have 7 newtons to the right, and that shows the resultant force. Okay, now, these are some other examples. So in this case, I've got 100 newtons pushing towards the right, and I've got 20 newtons pushing towards the left. Okay, so P is for push, F is for friction, so friction is trying to prevent it. So I do exactly the same idea. I'm going to do my 100 minus my 20, which will give me 80, and it'll move in the direction of the bigger force, so it will move towards the right, and it will move there by a resultant force of 80 newtons. Okay, now this one I've got a push of 20 newtons and friction of 20 newtons. Because the numbers are the same, those forces are balanced, so the box will stay where it is. Okay, because there's a resultant force of 0, because 20 minus 20 is 0. Okay, right, this last one. This time you've got a push of 50 newtons towards the right, and you've got a friction force of 20 newtons that's trying to stop it. My 50 minus my 20 gives me overall a resultant force of 30 newtons, and it will move in the direction of the bigger force, so it will move to the right because those 20 cancel out 20 of those, which leave 30, and it will move to the right. Okay, again, you've got some others that have a go on here, so pause the video and try and figure them out. In this case, I've got 20 newtons and it's going to move down, okay, because 30 minus 10 is 20, and the direction of the bigger arrow is downwards, so 20 newtons down. This one is going to stay there because 10 minus 10 is 0, so it's not going to do anything at all because those 10 cancel out those 10, it'll stay where it is. In this case, 45 minus 30 is 15. The direction of the bigger force is upwards, so it will be 15 newtons upwards. And then this one, I've got 30 minus 25, which gives me 5 newtons, and it moves in the direction of the bigger force, which will be to the left. So it's 5 newtons to the left. Now, what you are going to do, that's just another example, is you are going to have a go at these. Okay, so what I want you to do is on a piece of paper, I want you to draw out all the circles with the arrows, and you are going to first of all write whether it is balanced or unbalanced. Then you are going to calculate the resultant force, and then the third thing you're going to write is which direction it's moving. So I'll do the first one with you. So first of all, we've got 6 up and 5 down, so they're unbalanced. The first thing I write underneath this diagram is unbalanced. Then I'm going to work out my resultant force, so it's 6 minus my 5, which gives me 1 newton, and it will move in the direction of the bigger force, so 6 is the bigger number, so it will move upwards. So they're unbalanced forces, first of all, because the numbers are different. My resultant force is 1, 6 minus 5 is 1, and it moves in the direction of the bigger force, which is upwards. Now you're going to do this exactly the same for the rest of them, okay, and then I'll give you the answers tomorrow. do this.